Okay, so let's look at number 41. The easiest way to solve this problem is to actually push the arrows to break this polymer apart. And they're going to flow like this. So hopefully it's relatively easy to see that these bonds are all broken. Like so. And then multiple bonds are going to be made like so. And so we see that we have a CH2, CH, CH2, C triple bond N. That is most consistent with answer choice D. Number 42. We want the Iupac name for the following compound. So if we look at the longest chain, we know that we need to go from left to right. We're looking at 1, 2, 3, 4, 5, 6, 7, 8. They're all octadienes, but it should be a 2, 5 diene. That allows us to eliminate C and D. Now we need to look at the nature of the double bond. High priority, chlorine over the methyl, methylene over the hydrogen. This one, of course, is Z. And if we look at number 5, this one is also Z. This is one of those questions where we had a typo, and I changed A to 2Z, and I changed B to 2Z. A is the better of the two answer choices. So the credited response for 42 is A. Moving on to number 43, we have another nomenclature question. And another diene. I was just dying to say that. All right, so first of all, let's do the stereochemistry of the OH. 1, 2, 3, of course, the hydrogen is going away from us. So we can just go from 1 to 2 to 3. That's counterclockwise, so that is S, meaning we can eliminate A and D. And now we just need to look at the nature of our double bonds. This one is going to be Z, and this one is going to be E. So we're looking at a ZE, and that allows us to select C as the credited response. Number 44, we have a molecular orbital theory question. The more conjugated we have a molecule, the lower the HOMO-LUMO gap will be. So we actually need to have, just looking at the way 44 is worded, it should have been largest HOMO-LUMO and shortest wavelength, or shortest HOMO-LUMO and longest wavelength. So if we go for the first correction, the best answer is A. And I need to revisit y'all's responses on that question. I may have to throw that one out, which probably means I'll just give everybody a point. So if I want the shortest HOMO-LUMO gap and the longest wavelength, then obviously I want the azo dye. In fact, this is a very famous azo dye, and I should not be drawing this in green. I should rather be rendering this in yellow. Somebody asked me why. Why? Well, I'll tell you why, children. This is the dye that is injected into margarine or butter to give it its yellow appearance. In fact, the name of this compound is butter yellow. And if you didn't know that, you should know better than that. Sad. Now, if we're looking for the shortest wavelength and the largest gap, then we want D, because that has no conjugation whatsoever. So again, I'll have to review 44. May give you guys points. I may just chalk it up as being part of the curve. I really don't know yet. Number 45. We want the most thermodynamically stable compound. It's going to be the most substituted alkene. And let's just cut to the chase. It's going to be B, because all of the positions bonded to the alkene carbons are alkyl groups. More hyperconjugation stabilization. This means B is the best answer. Number 46. We want M plus and M plus 2 peaks in a relative ratio of 3 to 1. That is screaming chlorine atom. Of course, we know this because chlorine 37 has a mass of very close to 37. Chlorine 35 has a mass of very close to 35. The actual mass is 35.453. That's about 3 times closer to 35 than it is to 37. That gives us our ratio, because 3 to 1 would be about 75% to 25%. It's actually more along the lines of 74 to 26. But it looks like a 3 to 1 ratio. And so if we look at credited response D, this is the only molecule with a chlorine atom in it. Cumenyl chloride. That's answer choice D for number 46. All right, number 47. We're in the home stretch now. We want the stereochemical designation for the following molecule in the Fischer projection. Lots of ways we could do this. I'm just going to assign R and S based on going from 1 to 2 to 3 and then flipping my answer. If we look at this particular carbon, 1, 2, 3, and 4. So as I go from 1 to 2 to 3, I'm going clockwise. I'm going to flip that to counterclockwise. So that's S, meaning we can eliminate A and B. And then, of course, if we go to the second carbon, 1, 2, 3, 4, 1 to 2 to 3 is going S, and we're going to flip that to R. So it's SR, that's answer choice C. All right, last 3. Number 48. We want to rank these substrates from most reactive to least reactive. The larger the atom, the better the leaving group, because the more stable it will be. So we have the halides. We have chlorine. We have bromine. We have iodine. and we have fluorine. Remember on your periodic table, you have fluorine, then chlorine, then bromine, then iodine. So you want the most reactive to be listed first. So 3 is more reactive than 2, is more reactive than 1, is more reactive than 4. And that's going to be answer choice D. Okay, last two. Number 49. Which following compounds is most readily deprotonated with NaOH? Which is the best acid? So let's draw the molecules. If we deprotonate, this will be our product. This is non-aromatic. This is anti-aromatic. Remember, if the number of pi equivalents is divisible by 4, it's anti-aromatic. That is very unlikely to change. So let's get rid of A. We can look at B. Cyclopentadiene, non-aromatic. Cyclopentadienyl anion, aromatic. This is going to be our credited response. When you can go lower in energy from non-aromatic to aromatic, that's going to be a very stable conjugate base. So we really don't even need to look at number 50, or excuse me, at part C or D. All right, last one. Let's look at number 50. We're looking for valid resonance structures with this beginning structure. So one way we could push these electrons would be, you could do this. So here's 1, and we actually see this. We don't actually see this. If we look at A, it's exactly the same as the starting, so that one counts. If we look at B, we've just pushed. So we can do this. Push this back. And so that's structure B, so that one works. We can eliminate B. We could also push and push, and that gives us structure C. So we can eliminate C. The answer's got to be D. Now let's look at D real carefully, and I will give you a real simple explanation for why D has to be the right answer. And it's simple. Nitrogen is a second row element. Nitrogen cannot have an expanded octet. 2, 4, 6, 8, 10 electrons. No good. D cannot be correct. And we're looking for the one that's not correct. So D is the credited response for number 50. Now, I do want to say I'm going to do my best to screencast some important reactions, some important concepts that I would definitely practice over the weekend. And I hope to see you guys before Wednesday or Thursday so that we can go over some more of these types of problems. Happy studying.